Hey guys, all right, for this video, we are going to use a few formulas that we have already proven in the previous video, okay? And then we are going to use those to come up with different ones. So the first one we are going to use is this double angle right here, okay? Let me show you. It's gonna be this one. We'll use this one first, and then we'll use the next one next, okay? So the first one, we are going to use cosine of double angle, so double theta, equals 1 minus 2 sine square of theta. Okay, so that's our first one. Now, what am I going to do with this? What I would like for you to do now is I'm going to try to solve for the sine square. Okay, so solve for sine square of theta. So what I'm going to do next is I'm going to subtract the 1. And that's canceling. So now cosine of 2 theta minus 1 equals negative 2 sine square of theta. Okay. What I'm going to do next is now divide it by negative 2. Okay. Because I'm going to divide this by negative 2, this is now canceling. Now, the negative, I'm going to write this, sine square, I'm going to switch sides, okay, equals cosine of 2 theta minus 1 divided by negative 2. The negative on the bottom is quite ugly for both of us, so normally we like to make the denominator positive. So we are now going to change it to now negative cosine of 2 theta plus 1 all over positive 2. But the negative in front is quite ugly as well, so what we normally do in mathematics is that we like to put positive in the front. So now 1 minus cosine of 2 theta equals 2. Well, you know what this is? This is called power reducing formulas, okay? So this is one of them. So this is really important in calculus, so that's why if you go into calculus, okay, you should really know this, okay? So sine square is 1 minus cosine of 2 theta all over 2. Now we're gonna keep on going further, okay? So that's called a power reducing formula. And you only need to know this for calculus. That's why I'm bringing this up now. So I'm gonna keep on going. So from here, I will square root both sides, okay? Because I need a new formula for my regular pre-calc class, not calculus class, okay? So from here, when I take a square root, I will have sine of theta equals, when I take a square root, I should have plus or minus, big radical, 1 minus cosine of 2 theta all over 2. And that's all under the radical, okay? Then from here, what if I say, you know what? I'm going to do something, okay? So from here, okay, I'm going to say let 1 alpha be 2 theta. I know, remember? We manipulate these things all the time. So what am I going to do? If 1 alpha equals 2 theta, that means every time I see 2 theta, I can go and write 1 alpha in it. Would you agree? So I will now write sine, well, if 1 alpha is 2 theta, what is 1 theta? Okay, so let's think about this. If 1 alpha is 2 theta, then 1 theta, if I divide this by 2, right? 1 theta is alpha divided by 2. Would you agree? I need to erase this so that way, but keep that in mind, okay? So, well, sine of 1 alpha, if I were to, sine of 1 theta is now what? I no longer use a, but I'm going to use alpha divided by 2, okay? Equals plus or minus, big radical, 1 minus cosine, okay? Remember, 2 theta is now no longer 2 theta. I'm going to use alpha, okay? And this is the manipulation. Isn't that funny? Cosine of alpha all over 2. And that's what's called a half angle identity, and we will write it below. Okay, so my half angle identity, let's write it right here. Okay, so half angle identity is sine of alpha divided by 2. It's always plus or minus. And alpha, theta, beta, A, B, C, those variables don't matter as long as you know those all represent what? An angle, whatever angle we are using. Okay, so that's my first one. Then I'm going to do the same thing for what? Cosine, right? Because technically I can go and do the same thing. So let's use the double angle for cosine. Here we go. Cosine of 2 theta equals, but this time I'm going to use the one that has cosine in it, okay? So that one, meaning I'm going to use 2 cosine square of theta minus 1. And I'm going to do the same thing. I'm going to solve for cosine square. So I'm going to add both sides. Okay, so now I have cosine of 2 theta plus 1 equals 2 cosine square of theta divided by 2. Okay, so now I'm going to write cosine square over here. Cosine square of theta equals, I'm going to write the 1 plus cosine of 2 theta, not because it's any better, just because to keep it the same as this power reducing formula here. So this is cosine square of theta is now 1 plus cosine of 2 theta all over 2. Okay, so but I'm gonna have to go further because I'm solving for just cosine. Okay, so I'm gonna keep on going. Here we go. From here I will take the square root. If I take the square root, I will need to do plus or minus. So now I have cosine of theta equals plus or minus big radical 1 plus cosine of 2 theta all over 2. And just like earlier, I'm going to let an alpha be 2 theta. That means if I divide both sides by 2, that means alpha divided by 2 is 1 theta. Okay, so keep that in mind because that's my manipulation. So now I'm going to take out theta and put in 1 theta is, 1 theta is pi over alpha over 2 I meant. Okay, so now I'm going to write cosine of alpha over 2 equals, so plus or minus is still in the front, big radical, 1 plus, I'm going to take out 2 theta and put in alpha. You see that right there? So now cosine of alpha all over 2, and that's how they came up with the half angle for cosine. Okay, so I'm going to write that down below where half angle of cosine is. There you go. So cosine of half angle, and the reason it's called half angle is because it's alpha divided by 2 equals, yes, plus or minus big radical 1 plus cosine of alpha, extend that radical line all over 2. I will also need tangent of half angle, but tangent is just really what? Sine divided by cosine. And so when I do sine divided by cosine, the denominator of 2 will cancel out, okay? So when the denominator 2 will cancel out, I will now have plus or minus big radical, okay, sine on the top, so that's going to be 1 minus cosine of alpha all over cosines on the bottom, 1 plus cosine of alpha. And guess what? Do you need to memorize these? Yep, okay. Memorize. Okay, so these are the identities that now you need to know.